Hello all, welcome to Soumya's Tech Talks. Today in C++ lectures we will cover the smart pointers. We will deep dive into the smart pointers. Okay, let's start. Before going to smart pointers, first we should understand why the smart points are required. To know that, first we should cover the problems with the general pointers. Using the general pointer, what are the different general issues happens in our projects. We will cover and explain each one with some examples. Today we will cover only these two topics, and we will understand why the smart pointers are required. And in the next lecture we will start introduction of smart pointers, and also we will go deep into the smart pointers. Okay, let's start. So the main problem with the general pointers is memory leaks. So why memory leaks happens? So when you create objects using malloc in C or new in C++, the memory will be allocated from the heap, which happens in that runtime, not at the compile time. It is if you see the global variables, static variables, they always allocate from the BSS section or data section, which happens before even the program runs. So it is a pre-allocated memory, so there is no issue. They will live until the program is running. But heap memory is different. Like you create objects at runtime, use it. Once you use it, you will clear it. You have to delete it. For example, you are receiving messages from the network, Bluetooth or Wi-Fi. So whenever you receive a message, you will create a message object on heap, and you process the message object. Once process is completed, you will delete it. You cannot create static memory for that, or you cannot allocate global variables, because we never knows how many messages comes in the runtime, right? So we always pre-allocate some heap memory. From there we will create message objects from that heap memory, and once the message is processed, we will clear it. So, but there is some problems with heap. One is we forget to delete it. For example, we created a message object, we process it, but we didn't. Our code is not handling to delete it. So what happens? There will be lot of message objects created, but they are not freed, and there are a lot of memory leak, and your heap will be adjusted. So your heap will be overflown. So why it happens? Either you forget to free it, you didn't write the uh, instruction to free it, code to free it, or you have an instruction but that instruction is not executed, because before executing that, if there is a exception or return statements something, then it won't free it. We'll see with one example how the memory leaks can happen. So first scenario one, here see I created a new object of my class, and in this function, but before returning from the function I am not freeing it. So what happens, whenever you call this function many times, many objects will be created which is not getting freed, and your heap will be leaked, and there are a lot of memory leaks, and your heap will be uh, polluted, or your heap may adjust, overflows. So the second scenario is you have a delete, like before returning you have a delete, but the problem is, let's say code like this, divide by 0. So what happens, exception happens here, and this part of the code never executes. Okay, then what happens, your object won't be deleted. Okay, if your program completely terminates, it's okay, but otherwise this never happens. So this delete never happens. Okay, so second one is you are using the pointers. Let's say you already using a pointer, and you did a free, means deleting the data using the free, but again from some other source code, some other function or some other thread, you are trying to access that pointer which is already freed. It happens because when you have created a pointer and you will pass to some function, and from there you will call another function by passing same pointer, or you can pass a pointer to some thread. Okay, so the pointer will be shared to so many modules or components in our source code. But let's say one of the component or one of the thread or one of your source code function which delete the pointer, but others who is holding that pointer never knows that it got freed. Okay, then what happens if someone try to access, they will get crash. So that's why it is better practice to if it is a global pointer, we will set it to null pointer in C++ or null in C whenever we free it. Otherwise what happens if some of the code which is holding this pointer without knowing that it is freed, if they try to access it, they will crash. It normally happens in multi-thread programming where multiple threads may be accessing the pointer. uh, so in that case, if some thread uh, deletes the data pointing by that pointer, but other thread don't aware that, in that case if they try to access it, they will crash. We'll see with one example. Here let's say I have a structure and I have a global pointer which initialized to null pointer. So in the main I created that object like ptr equals to new of the structure. So it is created, and I created a thread and asking the thread to execute this function. So where I will access this pointer and also I modify it. Okay, if this is called, but let's say in this function, let's say I am deleting this data of this pointer, like delete ptr. What it will do, so whatever memory pointed by this pointer will be freed, so all data will be deleted. So this pointer is not valid, I am not setting to null pointer. Let's say this thread is executing and once this thread is completed, so it comes to main thread because the main function is running in main thread. So it never knows that the data is deleted, and it try to access it, it will crash. So normally in our regular projects or programs it happens if we don't care or we don't take the precautions using these pointers. We should always design properly so that once the data is deleted, the pointer should be set to null pointer, and also make sure that no thread or nowhere it is getting accessed after calling the delete once it is freed. Okay, so without smart pointers we have to take care of all these things. Okay, let's see another problem. Heap corruption. Heap corruption generally happens. For example, you are creating an array of elements, but you will have a pointer which points to starting address of the array. And before that, normally when you create heap array on the heap, so your array will be created, and just before the starting element there is a metadata. So we will discuss in further lectures how this metadata looks like, but let's say there will be a metadata which tells how much memory is allocated or how many items are created after this metadata. For example, you are pointing to metadata, you are pointing to the first element, your pointer is pointing to first element, and you free it. Then your system, runtime system, what it will do? So it will see the metadata. Based on metadata, once you call free, all elements will be deleted. So that is how it happens. Let's say when you are doing pointer arithmetics like addition to the pointer, adding something to pointer. Okay, why we'll do? Let's say you have a pointer which is point to first element. When you increment by 1, it will go to next element. Increment by 2, it will jump to third element from that position. So that's what our pointer arithmetic. You can decrement, you can increment, you can pre-increment, post increment, so many things we will do. So in that case what happens, your pointer may not be pointing to starting address. So without having idea about where it is pointing right now, let's say I increment this ARR, let's say I did ARR plus 5 or something. So without knowing that whether it is pointing to first element or not, if I call free or delete, okay, what happens? So the metadata is not available. So either you will get a crash, or it is try to free something. Let's say the system cannot free the data, and this memory will be useless, so no one can use this memory. So it will be until your reboot, this memory is corrupted, so no one can use it. That's how heap corruption happens in the when using arithmetic operations on the pointers. Okay, so we will see other problem. Let's say example of heap corruption, how it happens. Let's say I have memory array is created and initialize it, and now I have a pointer. So I did a pointer arithmetic ARR plus 7. So I have 5 elements, but I just did ARR plus 7, but then this bad pointer pointing to something out of this pointer. So we don't know what kind of who is holding that memory and what. So if we try to access it, delete it, or assign, add some copy some data to this bad pointer, you will get crash. So this is the problems of heap corruption. Okay, these are the problems we have covered. Now we know that what are the different problems happen in the general pointer. Next topics we will discuss more problems, and we will start introduction to the smart pointers and their behavior, and we also start the a smart pointer called unique pointer, and we will see how the unique pointer works in the background, in the behind the scene, how it is implemented, and we will see the some sample programs. Thanks for watching. So this is the end of today's lecture. So we will continue the C++ advanced tutorials. Please share these videos to your friends who are willing to learn, and also don't forget to like the videos. Thanks for now. Bye.